There are 5 basic components of central heat systems: burners, heat exchangers, distribution, outlets, and thermostats. A burner converts gas or oil to heat at temperatures reaching 800 degrees, or a resistance coil converts electrical energy to heat. At the heart of the furnace is a heat exchanger that transfers this heat from the flame to air or water. The toxic fumes produced here rise up and exit through the flue. One of the worst problems your heater can have is a cracked heat exchanger. When this occurs, toxic fumes that should be headed upward instead begin to seep into ducts and circulate through the house. If you ever smell fumes, shut off the heater and leave your house immediately. This is a rare event and usually happens in furnaces older than 20 years of age. Yet it's a good idea to have your furnace serviced once a year. The professionals will check out your heat exchanger for signs of trouble. There must also be a distribution system, such as pipes or ducts, to circulate air, water, or steam around the house. Heat is then transferred to the rooms by vents or radiators. Larger houses are more difficult to heat because the registers or radiators farthest from the furnace or boiler don't receive as much heat as closer outlets. To minimize this problem, warm air systems have dampers, hot water systems have throttling valves, and steam systems have air valves. The most effective location of a register or radiator is along an exterior wall near windows or doors. Here, heated air will mix with cold air that infiltrates the house through window or door joints. To get more heat into the farther rooms, reduce the flow of heat in registers closest to the furnace. Look for return grills on opposite walls of supply registers, or if there is a central return grill for the entire floor, it should be on the wall farthest from the door that leads to the floor. And last, there must also be a thermostat with a master shutoff switch somewhere near the furnace. When the temperature drops below the thermostat setting, electrical contact points close and activate the system. When the set temperature is reached, the electrical contacts open and shut down the system. Ideally, you want your home's humidity to be between 30 and 40% during the winter. Power spray humidifiers, as shown in the picture, are a great solution if you don't already have some humidifiers in rooms. Power spray humidifiers have a humidity sensing device and can be programmed with the touch of a button. Warm air systems are also popular because of their ability to adapt to central air conditioners, and there are no pipes that can freeze or burst. The biggest advantage of warm air systems is price. Installing a new furnace is only a third of the price of a hot water or steam boiler. Older homes may have gravity warm air systems. The large furnace looks like an octopus with many ducts coming out of it. There are no moving parts or motors, so this system works on the principle that warm air displaces cold air, thus causing air circulation. This system is considered obsolete, but if your house still has this system, it can be updated by installing a fan and motor assembly called a blower unit. A heat pump is a unique device. It can transfer heat from the outside to the inside for heating purposes, but can also do the reverse for cooling purposes. Of course, when the air outside gets very cold, the efficiency declines, which is why there are electric furnace coils incorporated into the system as an emergency backup. In heat mode, the outdoor unit pulls air across coils. Heat is then extracted from the air and transferred to a refrigerant, which is normally a gas, at atmospheric temperature and pressure. A compressor compresses the refrigerant to extract the heat and sends it to the indoor unit. This fluid travels to the indoor unit and a blower sends air to be heated across more coils. Outside, the unit should not be in a location where water can freeze to the blades of the grill. In other words, it shouldn't be under a leaky gutter. No bushes should be within 1 foot of the air intake on the side of the unit, and no tree branches should be hanging within 5 feet of the top where debris can settle. The unit should also be mounted on a concrete slab at least 6 inches off of the ground. Some homes are equipped with condensing furnaces. These were developed in the 1970s during the fuel crisis. Their high efficiency is the result of a second heat exchanger that extracts more heat from the exhaust gases that flow up the chimney from conventional furnaces. The temperature of the exhaust gases eventually reaches a point where the water vapor in the gas condenses and releases heat. A pulsed combustion furnace is another high-efficiency furnace. Heat is also extracted from exhaust gases like the condensing furnace. However, heat in a condensing furnace results from continuous burning of fuel, whereas a pulsed combustion furnace gets its heat from 60 to 70 tiny explosions per second of a gas and air mixture. Hot water systems work on the principle that water heated in a boiler can be distributed through pipes to radiators located throughout the house. When water is heated, it expands and increases its overall volume. To compensate for the extra volume, an expansion tank is needed and is often located in the attic. Without this tank, pressure would build up in the system and rupture pipes and fittings. The boiler water supply is taken from the house inlet supply. Your home supply of water has a pressure normally between 30 and 60 pounds per square inch. Water that is distributed through the heat system requires a lower pressure, usually 12 to 22 pounds per square inch. Therefore, a pressure-reducing valve is installed somewhere before the water enters the boiler. Boilers are made of cast iron or steel, cast iron being less resistant to corrosion over time. The lifespan of most boilers is anywhere between 20 and 30 years. The only time a boiler needs to be replaced is when leaks occur that can't be patched or fixed. Don't forget that condensation may form and mislead you. Gravity hot water systems, as with warm air, are now considered obsolete and inefficient. The same principles of hot and cold apply. As water is heated, it becomes lighter and displaces cold water back to the boiler for heating. The distribution piping is about 2 more inches in diameter than forced system piping. Gravity systems are classified as either open or closed. In an open system, the expansion tank has an overflow pipe extending to the atmosphere. Closed systems are not open to the atmosphere and have the ability to operate at higher temperatures. If you own a house with a gravity hot water system, or are interested in buying a house with this outdated system, the good news is it can be converted to a forced hot water system by installing a centrifugal pump and new controls. Forced water systems are identified by a circulating pump in the return pipe of distribution just before the connection to the boiler. There are 3 basic types of distribution systems available: series loop, 1-pipe, and 2-pipe. Series loop is the simplest and easiest to install. This is usually found in smaller homes where individual room adjustments are not needed to balance heat distribution. Baseboard convectors are present, and when the system is shut off, all water flow stops. Larger houses may be divided into 2 or more zones. A 1-pipe system is exactly that. 1 pipe serves as the supply and return. Radiators are attached to the supply pipe by 2 risers, 1 on each end. The radiators also have a shutoff valve located on the inlet riser, so room-by-room control is possible. 2-pipe systems have 1 supply pipe, 1 return pipe. Cool water leaving the radiator doesn't mix with the hot water from the supply main. Condensing boilers, as with condensing furnaces, increase the efficiency of the system by extracting more heat from exhaust gases with the heat exchanger and transferring the heat to water. Again, the water vapor in the gas condenses, giving up heat. Neither condensing furnaces nor boilers require chimneys for venting exhaust gases. Instead, a plastic pipe can be used to vent the gases through a sidewall. Both versions of this system require an intake air duct if outside air is being used for combustion. Both will have a power vent called an induced draft blower and condensation drain lines. Pulse boilers are also available to increase efficiency. Again, heat is generated as a result of 60 to 70 tiny gas explosions per second. The big drawback of the system is the noise it generates. Steam systems are very similar to hot water systems. They are no longer installed in homes but still exist in older homes. There is an easy way to tell if your system is hot water or steam. A water level gauge will be present on the boiler of a steam system. The water level in the gauge should be halfway to 2/3 full. Too much water will lead to leaks, and not enough water means water needs to be introduced into the system by manually opening the fill valve in the water supply line. Rather than pipes completely filled with water, only about 3/4 of the pipes are filled with water and the rest of the space is air. When the steam reaches the cool radiator, it condenses back into water and in the process gives up heat. The pitch of the radiator allows condensation to flow back to the boiler for reheating. The distribution piping for steam systems will be 1-pipe or 2-pipe configurations. The easiest way to tell which configuration you have is to look at the number of pipes connected to the radiator. In a 1-pipe system, each radiator has a supply valve and an air vent. 2-pipe systems do not have individual air valves on radiators, but instead have a steam trap on the condensate return pipe that allows air that is bound in radiators to escape through the main vent. The steam trap will close on steam contact, therefore keeping the steam within the system. An advantage of a 2-pipe configuration is that it can be converted into a forced hot water system. Now let's look at your ductwork. First and foremost, you want to make sure your ductwork is not electrically hot. This test can be done in your crawl space with a multimeter from the metal duct to the earth. You should get a reading of 0 volts. However, a few volts indicate a stray current and your ductwork needs grounded. Any reading over 50 volts means you are dealing with a hot duct, so don't touch. The rest of your observations should take place in each room with a vent opening. Make sure there is adequate airflow. And leaks in duct joints can usually be fixed with duct tape. Flue pipe should be at least 6 inches from flammables. Long sections should have some type of support every few feet. Metal flues that enter masonry chimneys can lead to problems. It's very hard to look inside of the chimney for debris and broken bricks, but if your flue pipe is corroded where it meets the masonry, chances are this needs repaired. Backdrafting occurs when gases that normally arise through a flue to exit a house reverse and flow back into the building. This commonly happens when the flue is cold and needs to be warmed up. However, this can also occur if the outside air pressure is higher than the pressure inside of the house. A good test to perform is to hold a mirror up to a potential backdraft area. Since moisture is carried in heated air, any backdraft will fog up the mirror. Almost everywhere, a wood-burning stove should have a 3-foot clearance from any combustible wall. Sometimes the wall is covered with brick or sheet metal to compensate, as it should. The legs of the stove should be at least 6 inches off of a non-flammable floor or floor covering. The flue pipe from the stove to the chimney should be as short as possible, with the crimped end of the flue pipe inserted into the stove collar. This prevents creosote from dripping on the floor. The clearance of the flue pipe should be at least 2 inches from flammables. Every stove should have a working damper to control combustion. In a worst-case scenario, if a flue fire began, you could cut the air off by turning the damper sideways. There are 2 basic types of fireplaces on the market: masonry and metal insert. Check for any major cracks in masonry that surrounds the firebox. It is very hard to identify the chimney lining is intact from the inside. However, on the exterior inspection of your house, if you see any creosote stain emerging from mortar joints, it is a good indication that the chimney lining is bad. You can identify a previous chimney fire by puffy, colored creosote, a distorted rain cap, or smoke stains around mortar joint cracks. In addition to liners, there should also be a wash cap to prevent rain from entering the chimney. Sometimes there is a grill network called a spark arrestor that prevents large sparks from leaving the chimney and setting fire to wood around the house.